Section 4 deals with functions. And a function is written, first off, with this to begin with. And it's called function notation. This here is just a label. It's like the name of the function. And you read that as f of x or f at x. And what a function is, it's a set of ordered pairs where each x has one and only one y. And when it's written, you would have, say, f of x is equal to, and then you would have some expression here. That expression can have numbers, it can have like a variable in it. The variable has to be x, but it could be just plain old 7, f of x equals 7, or you could have like 2x minus 5, or say x squared plus 10, or things like that. Some expression. And if it has a variable, it must have whatever variable is here. Now they use x a lot, but it doesn't necessarily have to be that. You could have like f of r. And then in any expression you have here would have to contain r in it. The domain of a function would be the x values. It's called the independent variable. It's also called the input value. That would be way back in like your middle school days. And the domain would be the values that can be used for the variable and then there's something called an implied domain. An implied domain is all the values that could be used. Difference between these two is in a domain, if they don't give you, well, they would give you one and it would fit the domain part. If they do not give you one, then it's an implied domain, and then you kind of have to look at it and figure out what values can you use. A lot of times the domain is going to be all real numbers. Not always, but quite a bit of the time, I think, with the ones you're going to deal with. And then the implied domain means that if it doesn't give you a specific set of values to use, then the implied domain means you got to figure out all of the ones that you could possibly use. And we'll go over an example of that in a little bit. And then the range would be the y's, the dependent variable. Also called the output. And it would be the answers you get. From substituting the domain values Nice spelling, huh? The domain values into the function. And so here we have three examples of functions. First one is f of x equals 3x plus 7. Second one is f of x equals square root of x. Third one is f of x equals 1 over x plus 2. So our implied domain for these, this one, 3x plus 7. You can substitute any number in for x and you can come up with an answer. So the implied domain would be from a negative infinity to infinity. Another way to say that would be all reals. With this one here, square root of x, the implied domain would be, well, you can take the square root of like 9 and 2 and 1 and 16 and 27 and 38, but you cannot take the square root of a negative number and have a real answer. It becomes imaginary. So the implied domain for this one is from 0 to infinity. Now you can include 0, so here's another way to say that would be by saying all reals greater than or equals to 0. And then this function here, 1 over x plus 2. Remember, you can never can't divide by 0. So what makes the denominator 0? Well, that would be a negative 2. So here it would be from a negative infinity to a negative 2, and then from negative 2 to infinity. And if you wrote it, it would be all not equal to a negative 2 is the other way to say that. And so that's what an implied domain would be. Sometimes they can give you a domain for this and just say like the domain is, from 3 to 8. Well, then that means you only need to use the values from 3 to 8 in your function. Like I said, if it doesn't say anything, then you kind of have to figure out what the implied domain is. And so with these, if you're just evaluating the functions, f of 9 means you would substitute 9 into the function. So here we'd have 3 times 9 plus 7, which would get you 34. Substituting 3 into this one, you'd have the square root of 9, which would get you 3. And substituting 9 in for this would put you at 1 over 9 plus 2, which is 1/11. Then f of r minus 1, that means now r minus 1 has to substitute in for x. So you would have 3 times r minus 1 plus 7. Now you can simplify this sum to get 3r minus 3 plus 7. So then you would have 3r plus 4. For here you would have the square root of r minus 1. And then that would be it. Here you would have 1 over r minus 1 plus 2. And negative 1 plus 2 is positive 1, so r plus 1 over 1. And then finally you could have it shown to you, a function shown to you graphically. Back here, these functions were shown to you algebraically. Now we have one shown to you graphically. So if we look at this problem here first says find f of a negative 1. Well, negative 1 here on the x-axis is right there. This is the point where it reaches the y-axis, or it's part of the graph. So what is this value? Well, it looks like it's approximately a negative 1.1. You just have to estimate unless it gave you the coordinate here. And then this one says f of 5, so now we would go over to 5, and that value up here looks like it is 3. Another way that they could ask you, say, what's f of x equal to -2? So in that case, now here's -2 on the y, because this is a y value. So when is x get you a value of -2? Well, that looks like it's right there and approximately right there. So x could be a positive 0.25 and x could be a positive like 2.25 or somewhere in there, because that's the x value right there and right there. In this particular problem, the domain then would be from a -6 all the way over to a +6, because it has all these values from here to there. And the range would be the y values, which would look like they go from here's the maximum one all the way down to here's the minimum one. So from a -2 to a +3, and it includes those values. So you would put brackets around them. If this would have been an open circle here, then that would have been a parenthesis, and that would have been a parenthesis. No, not that side. Sorry. That still would have been a bracket, but this would have been a parenthesis. Okay? So that is everything for this section. You may use the rest of the time today to start working on it.